So I'm going to label them just A, B, and C again. And let's go ahead and solve. Now, it doesn't matter what method we use. We could use one of the matrix methods we talked about last Wednesday, or we can use substitution, elimination, addition, whatever method works best for us. I'm looking at these, and I'm going to use the addition method. So I'm going to start out by adding equations B and C. So equation B, x minus 2y plus 2z equals 5. And C, negative x plus 3y plus 2z equals 10. Now you can see here the reason why I chose these two equations to add is when I add them, the x variable is going to disappear. X plus negative x cancels out. Negative 2y plus 3y gives us what? Y. And then 2z plus 2z is 4z. Equals? Perfect. 5 plus 10 is 15. So there is our first two-variable equation. Next, we're going to take a look at, well, we haven't used equation A yet. So we have to use equation A for something. I'm going to do A, and then I'm going to do 2 times equation C. So equation A is 2x minus 4y plus z equals 3. The reason I'm doing 2 times equation C is so that it'll cancel out the x. Since we canceled out the x up here, we have to cancel it out in these two down here. So 2 times equation C gives me a negative 2x plus 6y. 2 times 2z is plus 4z equals, and we got to remember 2 times 10, which is 20. And now we combine those. And again, the x is going to cancel out. 2x and negative 2x cancels out. Negative 4y plus 6y makes 2y. Z plus 4z makes 5z equals 23. Very good. There's our second equation. So now what we have is y plus 4z equals 15, and 2y plus 5z equals 23. And we have that two-variable system that we need to solve. What I'm going to do is I'm going to take this top equation and I'm going to multiply it by a negative 2. I'm going to rewrite it down here. Again, the reason I'm multiplying by negative 2 is that that'll make the y cancel out. Negative 2 times y is negative 2y. Negative 2 times 4z is negative 8z. Equals negative 2 times 15 is negative 30. So now 2y plus negative 2y cancels out. 5z plus negative 8z is negative 3z equals 23 plus negative 30 is a negative 7. So now we divide by negative 3 to get z equals 2 1/3. Anybody else come up with that? Yes? Okay. I wasn't trying to be that mean. I was trying to make those come out to whole numbers. We got to find y now. For y, we got to pick one of these two variable equations. I'm going to pick the top one. Y plus 4z equals 15. So that's going to become y plus 4 times 2 1/3 equals 15. Y plus 2 times 2 and 1/3 is 8 2/3 equals 15. And we subtract 8 2/3 to get Y equals 6 1/3. Now we have to go back to one of the original equations to find X. Doesn't really matter which one we use. Let's use this one here. X minus 2y minus 2z x minus 2y plus 2z, I should say, equals 5. So negative 2 times y is going to become 6 1/3, plus 2 times z becomes 2 1/3, equals 5. Oops, I did something wrong here. 4 times 2 1/3 is not 8 2/3, is it? It is 9 1/3. So this is going to be y equals 5 2/3. So this won't be 6 1/3 here. This will be 5 2/3. So then we multiply each of those out. Negative 2 times 5 2/3 is negative 11 1/3. 2 times 2 2/3 is 4 2/3. Equals 5. We combine. Negative 11 1/3 and a positive 4 2/3 is a negative 6 2/3. Equals 5. And finally, we add the 6 2/3. X equals 11 2/3. So you get the ordered pair, X, or the ordered trio, I should say. X is 11 2/3, Y is 5 2/3, and Z is 2 1/3. Anybody actually come up with that? Cool. Now, using the matrices, there's a shortcut for this. Again, you're not going to be required to do any of the matrix stuff for tests or anything like that, but I just wanted to show you. So this is already defined to be a 3 by 4 matrix, which is the right size here. That'd be 2, -4, 1, and 3. That's just the top row, 2, -4, 1, and 3. Second row would be 1, -2, 2, and 5. Third row, -1, 3, 2, and 10. We get out of there, and then we got to do matrix math. RREF for reduced row echelon form. Of matrix A. And there we get the 11 2/3, 5 2/3, and 2 1/3. So the matrices help us reduce the amount of work, and it allows us basically, as we saw there, to use technology. As we saw on Wednesday, if you do them by hand, it doesn't save a whole lot of work. The next thing we want to look at, the next level of progression here, to review a little bit, we graphed things like 3x plus 2y is less than or equal to 6. How did we graph that? What's our first step? Well, just like graphing lines, we have to make it y equals, don't we? Or get y by itself at least. What do we have to do to get y by itself? We subtract 3x from both sides. We have 2y is less than or equal to 6 minus 3x. What's next? We divide by 2. Y is less than or equal to, we haven't flipped the symbol at all because we didn't divide or multiply by a negative. 6 divided by 2 is 3. Negative 3x divided by 2 is negative 3 over 2 times x. When we graph that, we're going to graph it just like a line. Where would we start? 0, 3. Y-intercept of positive 3. From there we would go down 3 over 2. Maybe down 3 over 2 again if you wanted to. Now, since this is an inequality, we have to stop and ask, what type of line are we going to draw? Solid or dotted? Or dashed, I should say. Because it's less than or equal to, it is a solid line. Good. We pick a test point, 0, 0. If I put in 0, 0 here, 0 for x and 0 for y, does it make that true? Yeah, 0 plus 0, is that less than 6? Yes. So that point, 0, 0, is in the solution of this. So that means we're coloring in this side of that line. So that shaded region, along with the solid line, is the solution to that inequality. While we've been talking about multiple equations together, it's time we talk about multiple inequalities together. What if we then also have x minus 3y is greater than 9? Well, first we would have to graph that. What's our first step going to be to graph that? Subtract x. Good. So we've got negative 3y is greater than 9 minus x. What would be next? We divide by negative 3. So I've got y. What happens with our symbol? We flip it. Because we divided by a negative, it has to change directions. That gets flipped over. So 9 divided by negative 3 is negative 3. Negative x divided by negative 3 is positive 1/3 x. So where do we start at? 0, negative 3. Good. And from there we go up 1 over 3. Solid or dashed? This is a dashed line because it's just strictly greater than. If I choose that test point of 0, 0 again, is 0 minus 3 times 0 greater than 9? Is 0 minus 0 greater than 9? No, so that point is not in the solution. So we color in the other side of that line over here. Well, since we're looking at systems, remember when we graphed lines, we did systems of equalities. It was the point that makes both equations true, or 3 equations true if we're looking at multiple equations. Here it's not equations, it's inequalities, so it's points that make both of them true. And so for this, that would be where they overlap. Well, they overlap over here. This region is shaded in both graphs. But we also have to get the boundary conditions. This boundary would be solid because that's a solid line there. This boundary would be dashed, telling us that points that are on that line aren't included, but all the points right up to it are. So that is the solution to that system of inequalities. It's that graph. In your notes, I want you to graph this system of inequalities quick. See what you come up with. Subtract the 5x. Get negative y is less than or equal to 2 minus 5x. Then we divide by negative 1 to get rid of the negative. We get y is greater than or equal to, because we have to flip the inequality, negative 2 plus 5x, or 5x minus 2, however you want to look at it. Where do we start on our graph? 0, negative 2, good. And from there we go up 5 over 1. Dashed or solid? It is a solid line. 0, 0 is kind of hard to pick out where it's at. It's definitely on this side. But if you weren't sure, it'd be a little tricky. I'm going to use the point negative 5, 0 as a test point. Let's try that out. So if x is negative 5, is that less than 2? Well, 5 times negative 5 is negative 25. Negative 25 minus 0 is negative 25. Is that less than or equal to 2? Well, it sure is. So that's saying that the solution here is on this side. Next one down. What's our first step here to graph this? We subtract 3x. Good. So 2y is greater than 6 minus 3x. And then divide by 2 to get y is greater than 3 minus 3 halves x. So we're going to start at 0, 3 and then go down 3 over 2. And this one will be dashed. And this one, 0, 0 is pretty easy to pick out right there. So I'm going to do 3 times 0 is 0. 2 times 0 is 0. Is that greater than 6? No. So it's the other side that gets shaded over here. So our solution where they overlap is this wedge up here with a dotted border on this side and a solid border on that side. Any questions?
Yeah, so for the 3x plus 2y is greater than 6, instead of rewriting it, I just went, alright, x is 0, so y is 3, and then I went y is 0, so x is 2. Like that.
Yep, you can graph it by plotting points like that, using the intercepts in that case.
Okay.
Yep. It is possible to have more than 2 inequalities to make a graph. We might have y is greater than 0. Two x minus y is greater than 3. And 3x plus 2y is less than or equal to 4. So when we go to graph these, it could give us a region just like we had before, but now we need all 3 of these to overlap. Or it could now, since we have 3 equations, 3 lines, of course, is capable of making a triangle. It could possibly enclose a region. So let's start out with this one. Y is greater than 0. Y equals 0 is a horizontal line which is basically just the x, well, not basically, it is the x-axis. Greater than 0 means we color in the top of it. Two x minus y is greater than 3. You could do what Ezra did there and just say, well, 3 divided by 2 is a 1.5, so it intersects x at 1.5. 3 divided by negative 1 is negative 3, so it's going to intersect y at negative 3. But let's go ahead and solve it. We'll subtract 2x. Negative y is greater than 3 minus 2x. And we divide by negative 1 to get y by itself. Y is less than negative 3 plus 2x. So negative 3 up 2 over 1 looks like that. It's a dashed line because it's strictly greater than or less than. If I pick a test point, 0, 0, and put it in there, 0 minus 0 is not greater than 3, so that's false, telling us we shade in the other side over here. The last one, 3x plus 2y is less than or equal to 4. Let's subtract 3x. Here's 2y is less than or equal to 4 minus 3x. And we divide by 2. Y is less than or equal to 2 minus 3 halves x. So we start at 2. We go down 3 over 2. It's going to be a solid line. I didn't plan that out very well. Our test point 0, 0, if we put that in, 3 times 0 is 0, 2 times 0 is 0. 0 plus 0 is less than 4, so it's true there. So we color in this side. What we get here for a solution region where all of them overlap is a very, very tiny triangle right here. If I made that triangle bigger, it would be dotted on these two sides and solid on this side. Because this line's solid, these are both dashed. So that little region there is the solution to this system of inequalities. I was trying to make it a little bit bigger than that. That's okay. You guys should get the point, right? Any questions? Okay, well then, let's take a look at our next algebra topic, which is variation. Variation describes the relationship between two numbers. When one number changes, what does that say about the changes that we should expect in another number? And for most things, there is a definite relationship. There's one of two relationships. The first one is something called a direct relationship. In direct variation, if one number gets larger, the other number has to get larger in a related manner. Or you could look at it the other way around. If one number got smaller, the other number also gets smaller in a related manner. Direct relationships, direct variation, is often referred to as a constant ratio. The ratio of two values, the relationship within that ratio is going to stay the same. Well, what does that mean? Let's look at electricity. Voltage equals 120. Oops, sorry. Let's say voltage equals 30 amps times whatever our resistance is. we can find consistently that whatever the resistance changes, the voltage goes up in a predictable manner. It's a constant ratio. This, of course, gives us one of our forms. There's two standard forms for direct variation. A constant ratio, if we're looking at the variables being x and y, you might look at it as, actually technically do y over x is equal to a constant. We use k for that constant. Another way of writing it is if you solve it for y, is that y is equal to a constant times x, which is the form we ended up here. Y is equal to 30 times or voltage is equal to 30 times the resistance. That's a constant times our variable. So if we're told y varies directly as x, or y varies directly with x, what that is telling us is that we have that relationship. Y equals a constant times x. Now generally there's more information than that. We might be told y varies directly with x, when y is 18, x is 6. So what's that telling us? Well, y varies directly with x still means y equals a constant times x. But this next piece, when y is 18, x is 6, that's saying we can put 18 in for y and 6 in for x. And as a consequence of that, we can find what that constant is. We divide by 6, we get that 3 equals that constant. So now we can combine that with our general form to get y equals 3x is the relationship that we're looking at there. So then often our next step might look like y varies directly with x when y is 32, x is 4, find y when x is 7. So again, y varies directly with x. It's telling us y equals a constant times x. When y is 32, x is 4. This is what's often referred to as an initial condition. We have the relationship here, gives us the general form of the equation. That initial condition helps us figure out the values of the constants in that. So we put 32 in for y, 4 in for x. So 32 equals k times 4. Now we solve. We'll divide by 4 to get that 8 equals k. So we combine that with our original form. We put in 8 for k, y equals 8 times x. And now we have that last final request that we're asked to find here, question being asked. Find y when x is 7. So y equals 8, we put 7 in for x. 8 times 7 is 56. So when x is 7, y is 56. Any questions there? So I'm going to have you try one of those. Y varies directly with x. When y is 12, x is 4, find x when y is 63. I'll give you a minute to find that. Y varies directly with x, tells us y equals a constant times x. When y is 2x is 4, or y is 12, x is 4, we put 12 in for y, 4 in for x. We divide by 4 to solve for k to get 3 equals k. So that tells us that y equals 3x. And then find x when y is 63. Now, I gave you y, so you put 63 in for y, solving for x. To solve for x, we have to divide by the 3. 21 equals x. Any questions there? So what are some examples of direct variation? Well, there are a lot of them. Rate and distance is a big one, like speed and distance. You know, if Sam travels 480 miles at 60 miles per hour, how far could Sam go in the same amount of time at 70 miles per hour? Now, many of us have worked with problems like this without knowing that it's a direct relationship. But there's a direct relationship here. The distance traveled is equal to a constant times the speed. So we put in 480 miles as a distance when that speed is 60, tells us the constant equals 8. In other words, they traveled for 8 hours. So that distance equals 8 times the speed. And now asking how far could they go in the same time at 70? Well, it's 8 times 70. That distance would have been 560 miles. One that's actually very important in physics is something called Hooke's law. When we talked about weight and mass, we mentioned Hooke's law. What Hooke's law is saying is the distance that a spring stretches is directly related to the force that's applied to it. So that distance is equal to a force times x, which is a constant of the spring. So if I have a spring where I know it stretches 8 inches under 20 pounds of force, then I can now then predict, well, how much force would it take if it stretches 10 inches? So it stretches 8 inches under 20 pounds of force. So I put 8 here, 20 there for F. If I solve for X, I divide by 20. I get 0.4 equals X. What that's saying is that this stretch will be 0.4 inches for every pound applied. So D, that distance, equals 0.4 times X. Sorry, D will be F times 0.4, I should specify. That force times 0.4. So in the second part, if it stretches 10 inches, what was the force? So I put 10 there. F times 0.4, we will solve by dividing by the 0.4. We get 25 equals F. That would be 25 pounds to stretch it 10 inches. So you can see here, if we know it's a direct relationship, we can take a set of initial conditions and use it to create the formula. Now there's one thing that, of course, is required here, and that is a 0 point. In both of these examples, we knew that both variables were 0 at the same time. Here we knew if there was 0 force, there was 0 stretch. Up here we knew 0 speed, 0 distance. If you're not moving, you're not going to go anywhere. So that's one of the requirements. If there's not that 0, 0 point or that origin point, then we would need 2 initial conditions to figure out the equation. If I say y varies directly with x, when y is 13, x is 5, and when y is 21, x is 9. So what this is telling us is y varies directly with x. It tells us y equals a constant times x, but there might be plus some sort of a y-intercept. We don't know. We don't know that it has that origin point or that 0, 0 point. So we take one of the points here, y equals 13 equals k times 5 plus b. And we're going to take the other origin, the other initial point here. Y is 21 when x is 9, so k times 9 plus b. Well, guess what we have here? We have 2 equations in 2 variables. We're solving a system of equations to find k and b, and we have the formula for that relationship. Now, it doesn't always stay quite that simple. You might have y varies directly with the square root of x. When y is 42, x is 9, find y when x is 4. So, of course, what's slightly different here? square root, right? So it's not going to be y equals kx. What's it going to be? It doesn't vary directly with x. It varies directly with the square root of x. So y equals k times the square root of x. Then what do we do? What goes in for y? K times what? Square root of 9. Perfect. So we take the square root of 9. That's k times 3. And then we divide by 3 to get k alone, to get that k equals 14. So y equals 14 times the square root of x. Find y when x is 4. What do we do? Fourteen times the square root of 4. So 14 times the square root of 4 is 2. So y equals 28. What do you think? Not so bad? Okay. Well, the next type of variation we can talk about is inverse variation. In inverse relationships or inverse variation, if one value gets larger, the other value has to get smaller in a related way. Or the opposite would be true. If the first value gets smaller, the second value has to get larger in a related way. Inverse relationships are not constant ratios. They are considered to be constant products. So what that means is one of the forms could be x times y equals a constant. Now, we've been having things in the form of y equals, just like we did with direct. If we solve that for y by dividing by x, we get y equals a constant divided by x is the main form, or one of the main forms, for inverse variation. So if I'm told, or we're given, y varies inversely as x, that's telling us y equals a constant divided by x. Well, just like last time, there can be more to it. Y varies inversely as x when y is 8, x is 6. Find y when x is 3. Now before we break any of this problem down, let's look at the numbers. X started out as 6 and it becomes 3. So did x get smaller or larger? X got smaller. So y has to get bigger. Yeah, whatever x does, y has to do the opposite. So now we look over here. Let's break it down. Y varies inversely as x. That's y equals a constant divided by x. Our initial condition, when y is 8, x is 6. We put in 8 for y, 6 for x, and we'll solve for k. We multiply by 6. 48 equals k. So that gives us the equation is y equals 48 divided by x. And finally, find y when x is 3. We put in 3 for x. Y equals 48 divided by 3 is 16. Y equals 16. Any questions? So some examples for you guys to try. We'll start out with just y varies inversely with x. When y is 20, x is 6. Find y when x is 30. I'll give you guys a minute or so to work through that. So varies inversely means y equals k divided by x. If y is 20 when x is 6, we put in 20 for y. 6 for x, so 20 equals k over 6. We multiply by 6 to get k by itself, giving us 120 equals k. So that relationship becomes y equals 120 over x. Find y when x is 30. We put 30 in where the x is. 120 divided by 30 is 4. Y would be 4. Examples of inverse relationships. So we looked at speed and distance, speed and time. Let's say it takes Pat 8 hours to reach a destination at 56 miles per hour. How long would the same drive take at let's do 64 miles per hour. So we have time and distance. Or time, and speed. It doesn't matter which one we put where. I'm going to put time equals a constant divided by the speed. In this case, the constant's actually representing the distance traveled. So then, the time is 8 hours when the speed is 56 miles per hour. If I multiply by 56, 8 times 56 is, 448 equals k. giving us that the time it takes is going to be 448 divided by S. How long would it take at 64 miles per hour? We put 64 in there. 448 divided by 64 is going to give us a decimal. Nope, it doesn't. Exactly 7. That'd be 7 hours. Any questions? Other examples could be pump size and the time it takes to fill a tank or empty a tank. If you get into chemistry, there's something called the ideal gas law. What the ideal gas law says is the volume of a gas is inversely related to the temperature it is at. Or not the temperature, to the pressure it experiences. The reason temperature was going through my head is because this requires that the temperature is constant. As long as the temperature doesn't change, the volume of the gas is inversely related to the pressure it experiences. So let's just say we're told that at 40 psi, the gas is 300 cubic inches. Let's find the volume at 60 psi. So our pressure and our volume are inversely related. So volume equals the constant divided by the pressure. So 40 psi equals K over 300 cubic inches. Oops, I got that backwards. Our volume should be 300. K divided by our pressure of 40 psi. K is going to end up being the same either way, though. We multiply by 40 to get K by itself. You get that K equals 12,000. So the volume is 12,000 divided by the pressure. Find that volume at 60 psi. Well, 12,000 divided by 60 gives that volume is 200 cubic inches, inches cubed. Any questions there? Okay. Well, there's something called joint variation. Joint variation is a combination of inverse and direct. More often than not, up above we held a constant. We said the volume is inversely related to the pressure if the temperature is constant. The voltage is directly related to the resistance if the current is constant. Well, notice there are other values involved there that we're holding constant. More often than not, there's more than two items involved in a relationship. And that's usually where joint variation comes in. In joint variation, there's one value that's related to the others directly. Like in the pressure. The volume is technically equal to, actually these are different. Let's use the electricity. The voltage is technically equal to the current times the resistance. Now notice there's no constant here. You can think of it as that constant equals 1 if you wanted to. But you'll notice the voltage is directly related to the current, because if the current gets larger, the voltage gets larger. The voltage is also directly related to the resistance. If the resistance gets larger, the voltage has to get larger. The relationship between the current and the resistance, however, is more complicated. If the voltage doesn't change, if the current gets larger, the resistance has to get smaller. So that is an inverse relationship. So joint variation, one variable, in this case the voltage, is directly related to two other variables, but those two other variables must then be inversely related to each other. So both the current and the resistance are directly related to the voltage, but they're inversely related to each other. I don't usually spend a lot of time with joint variation because the next step is combined variation. Combined variation is talking about three or more variables again, but the relationship can be done in any form. We might say that P varies directly with the square of M and inversely with T. What does that mean? Well, P varies is our first start. That's saying P equals a constant, and something's being done to that constant by our other variables. Well, directly with the square of M, that's saying M is multiplying K. More specifically, the square of M is multiplying K. So it's K times M squared. And inversely with T. So that constant K is being divided by T. We might be told that P is eight when, let's see, M is 4 and T is 20. What's that going to tell us? Well, we can put 8 in for P. There's our constant times M is 4, so that's 4 squared. Over T is 20, that's 20 there. And now we go ahead and solve that for K. First thing we should probably do is square the 4. So 8 equals K times 16 divided by 20. We could combine the 16 and 20, but it's easier to multiply by the 20. 160 equals K times 16. Then divide by the 16 to get 10 equals K. So this relationship is actually P equals 10 times M squared over T. So I'm going to have you guys try an example of this, and then we're going to call it a day. F varies inversely with the square of D and directly with n. When D is 3, n is 5, oops, not, F is 18. Find F when D is 4 and n is 2. I'm going to give you a couple minutes to give that a shot, then we'll go over it. So F varies. So F equals a constant inversely as the square of D. So K over D squared. And directly with N. So F equals K times N over D squared. So D is 3, so I'm going to put 3 squared there. N is 5, so K times N. F is 18, so let's find out what K has to be. This will be 18 K times 5 over 9 once we square the 3. We could multiply by 9, gives us 162 equals K times 5. Dividing by 5 gives us K equals 32.4. So that means F equals 32.4 N over D squared. Now I want us to find F when D is 4 and N is 2. So 32.4 times 2 over 4 squared. I'll do the top first. 32.4 times 2 is 64.8. On bottom, 4 squared is 16. 64.8 divided by 16 should give us 4.05. Good. If you get 4.05, any questions on how we do these? Okay, well, this is week 12, so homework 12A. Covers the material from today. We'll see you all tomorrow. Have a good day.